Hey guys, it's me. So I'm still grading your assignment 6. I've gone through a lot of them, but haven't finished them all. But what I have seen is that a lot of people were struggling with the absolute value stuff. Not the equation so much, more the inequalities. But it's really the first thing I've seen all quarter where, like, even people, for example, that went through and got all the questions right, you picked the right answer, but then when I looked at your work, the work that you had was just not correct. Like, you were not doing the right method at all. You still managed to pick the right answer. However that happened, I don't care. But I'm concerned that people just don't really fully understand the method, in particular for how to solve the absolute value inequalities. So I thought I would just do a short-ish bonus lecture just to review that particular section, with section 9.3 from the book. Okay. All right, so the objective for the section that's solving absolute value equations and inequalities. So first of all, just what absolute value is. The absolute value of a number is its distance. Its distance from the origin on the number line. How far away is it from 0 on the number line? Okay. Because it is defined as a distance, it is always positive or 0. A distance physically cannot be negative. Okay, so absolute value is always non-negative. So technically here, from the book is the definition of absolute value. If a number is already greater than or equal to 0, then the absolute value is just equal to the number itself. If the number is negative, then the absolute value is actually the opposite of that. In other words, it's a positive number. Okay. So just as a very simple example, I always like to start very small with absolute value and build, because I do think it's a confusing topic. So for the most basic example, if the absolute value of x equals 4, what are the solutions for x? What can x be? Well, obviously, either x can be 4, because the absolute value of 4 is equal to 4, or x can be negative 4, because the absolute value of negative 4 is also equal to 4. Okay? Because both 4 and negative 4 are a distance of 4 units away from the origin, from 0. Okay? Remember, distance, it's a physical quantity. It's always a positive number. All right, so real quick, the properties of absolute value. This is basically just kind of showing you how to simplify absolute value expressions. For example, if you have the absolute value of something times something, you can just separate them out and multiply them separately. Same thing for a quotient. Absolute value of something divided by something, you can just separate them out into 2 separate pieces. If you have the absolute value of the negative of something, it's just equal to the absolute value of the something. And the reason for that is, when you have this, the absolute value of negative something, that negative sign really means negative 1 times a. So then really, we're just applying the first property. We're just separating those out. It's same as the absolute value of -1 times the absolute value of A. And of course, the absolute value of -1 is just +1. So it's just the absolute value of A. Okay. All right, this next piece at the bottom of the page, I'm going to skip. I looked carefully at the department syllabus, and they did not specifically include that. So let me just move on to the next page, which is equations with absolute value. And actually, everybody did fairly good on this. There was just one on the assignment, but I just want to make sure. Okay. So we've got the absolute value. So before we had just plain old absolute value of x equals 4. So now we've just added one more thing. Now we've got the absolute value of x minus 1 equals 4. So basically, the absolute value of some stuff equals 4. Well, it's really the same concept, because before we said, well, then this has to be either 4 or -4. Well, exactly the same concept here. So either the stuff, the x minus 1, has to equal +4, or the stuff, x minus 1, has to equal -4. All right, because that way when you take the absolute value of it, you end up with +4. So now that we've removed the absolute value bars, now it's just a very simple matter. In this case, add 1 to both sides. You get x equals 5. On this case, add 1 to both sides, and you get x equals, let's see, -4 plus 1 is -3. So x either equals 5 or -3. You could take either of those values if you wanted to check and just plug them back in to the original absolute value equation and verify that they work. Okay. So this is basically just summarizing what we just did, the technique for solving when you have absolute value of some stuff equals a number. Okay, so the solution of absolute value of stuff equals a number. It's either the stuff equals the positive number or the stuff equals the negative number. Okay. So one comment is on what we just solved, absolute value of x minus 1 equals 4. Okay, you cannot start trying to simplify the original problem by just adding 1 to both sides. You can't jump in there and just add 1 to both sides. Okay, that doesn't work. All right, so there's 2 important steps to do when you're solving either an absolute value equation or an inequality. The first step is you have to isolate the absolute value term. And I did see people not doing this on the assignment problems. So by isolate, I mean you want it alone on a side with nothing else there. It should be the only thing. So you've got the absolute value of something, and then you either have, you know, an equal sign or some kind of an inequality or whatever, and then you have over here some number. Okay, that's the first step. Then the second step is to remove the absolute value bars. And you know, you can't just erase them. They don't just go away. What I mean when I say remove the absolute value bars is apply one of the techniques. Okay, so for example, this is the technique right here for removing the absolute value bars for an absolute value equation. Okay. All right, and then just one last little comment down here at the bottom. What if our problem had been the following? Absolute value of x minus 1 equals -4. So just kind of be on the lookout for this. Don't just try to apply the technique and solve. This is kind of a trick question because the absolute value of anything will never be a negative number. It's not possible. By definition, absolute value is either positive or 0. It is never negative. This is just not possible. So the solution is basically no solution, empty set. Okay, let me move on. Equations with two absolute value expressions. And by the way, there was not one of these on your assignment, but I did put a note in the test study guide that I do think there's one like this on the test next Monday. So this is something that you should look at. And it could also turn up on the final. Who knows, right? So we're talking about the technique to solve if you have the absolute value of one expression equals the absolute value of some other expression. Okay? So in other words, you have like this. The absolute value of one expression equals the absolute value of another expression. Okay? So each expression essentially just equals some number. And if the absolute values of those numbers are equal, then it means that this stuff and this stuff, A and B, are the same distance from 0 on the number line. Okay? Therefore, they are the same number or they are opposites. Okay? So they're the same distance from 0 on the number line. Therefore, they are either the same number or they are opposites. So the technique to solve this equation is to either set them equal, they're the same number, okay, or to set one equal to the opposite of the other, okay? Then just solve both of these equations. The only tricky part is to write the opposite of B correctly. This part right here, okay? You have to remember to change the sign of every term. Okay, it doesn't mean just put that minus sign out in front of the first term. You have to change the sign of every term. So for example, I've got absolute value of one expression equals absolute value of another expression. Okay, so apply the technique. So then either 5x plus 7 is just straight up equal to 4x plus 3, or 5x plus 7, that's the first one, the A, is equal to the opposite of that number. So negative of quantity, 4x plus 3. Okay. So here's what I'm saying. You have to make sure you apply that minus sign to both of those terms, okay? So now we just have two simple linear equations. We're just going to solve them both. In this case, I'm going to subtract 4x from both sides. 5x minus 4x is just 1x. And then at the same time, I'm going to subtract 7 from both sides. So over here, I have 3 minus 7. So in other words, x equals -4. Or Okay, let's just write this one out one more time. Remember, we have 5x plus 7 equals, so negative 4x, and then minus 3. Okay. All right, so to solve this guy, okay, I'm going to add 4x to both sides. So plus 4x plus 4x. So I end up with 9x over here. And then to move the numbers over, I'm going to subtract 7 from both sides. So minus 7 minus 7. So I have minus 3 minus another 7. So that equals negative 10. And then just last step, divide both sides by 9. And we end up with x equals negative 10 ninths. Okay, so two solutions, either x equals negative 4 or x equals negative 10 ninths. Okay, so let me move on to inequalities with absolute value. All right, so let's kind of go back to the first problem we solved, which was absolute value of x equals 4. It's exactly equal to 4. So then we said the solutions to that were either x equals negative 4 or x equals positive 4. In either case, you take the absolute value and it's equal to 4. Okay? So now we're going to write an inequality though. We're going to write absolute value of x is less than 4. Okay? So in this case, the solution is going to be an interval of values. Okay? As opposed to just the two discrete solutions that we had to our previous equation. It's going to be a range of values. And, you know, just keep in mind, what does it mean? What does a statement mean? It means what values of x are less than 4 units away from the origin on the number line. Okay, so here's the origin at 0. So what numbers here are less than 4 units away? Well, anything from here, yeah, 1 is less than 4 units away, 2 is less, 3 is less, all the way up to, oh, but not including 4, because 4 is not less than 4. All right, so we're not going to include 4. And then also, if we start at the origin and go the other way, am I less than 4 units away? Yes, yes, yes. All the way up to, but not including negative 4. That whole interval, any point in that interval, is less than 4 units away from 0. Okay? So the solution is going to be everything between, but not including, negative 4 and 4. So in interval notation, parenthesis, negative 4, comma, 4. All right, that is the solution to that. Now, if we just slightly change the problem, here we had less than, now we're going to say, where is it less than or equal to 4 units away? So you can probably see from what we drew here that it's going to be almost the same. The only difference is that we're going to include the endpoints at negative 4 and 4. And it's going to still be that same interval. Okay? So in this case, it's going to be a hard bracket, negative 4, comma 4 bracket. So, and yeah, everybody, please make sure you remember the difference between the hard bracket. It's like clamping down on that number. It's including that number. versus the soft paren, which does not include the endpoints, okay? Because I did also see people making mistakes like that on the assignment. I don't want you to make a mistake like that on a test. So you also just have to look very carefully at the answers. Are they parens or are they brackets? Okay. All right, going to go on to the next page. So that was a less than example. Now let's look at a greater than example. Okay. So now we've got this problem. Absolute value of x is greater than 4. And again, just as before, the solution is going to be an interval of values. Okay, not just certain discrete values like the equation. So this statement means what values of x are more than 4 units away from the origin on the number line. So again, here's the origin, just at x equals 0. Which numbers are more than 4 units away? Well, let's see. Start at 0. Is 1 more than 4 units away? No. 2? No. 3? No. 4? No. But anything greater than 4? Yes. Anything above 4 is more than 4 units away, going, all the way on up to infinity. All right, if we start at the origin and go to the left, what's more than 4 units away? Here, no, that's only 1 unit. 2 units, 3 units. 4, I want to be more than 4, so I got to go just past -4, but not including it. And then everything else down here, all the way down to -infinity, is more than 4 units away. All right, so we've got 2 pieces to the solution, here and here. So in this case, we need to write it as a union in interval notation. So it is -infinity, comma, -4, paren, union with paren 4, comma, infinity. Okay. And then if we just make this one change instead of greater than, what if it's greater than or equal to? So just like the previous example, the only change is, okay, now I want to include the endpoints here. So in other words, I want this, and I want this. Okay. So my solution here would be -infinity, -4, hard bracket, union with bracket, 4, infinity. Okay. All right, gonna erase and go on to the next page. And for those of you that did already get my feedback from, let me make this a little smaller, from your assignment 6, I recommended that you look at this summary, and let me just find the page real quick. It is on page 661 of our textbook. Okay. And this is a really, really great summary of the methods for solving absolute value equations and inequalities. Okay. So this first part here, A, is what we already looked at, solving an equation. If you've got absolute value of some stuff equals a number, then the solutions are either the stuff equals the opposite of the number or the stuff equals the number. Okay, and they give you an example here, so you can go ahead and run through that. All right, so here's the new stuff we're talking about now, the inequalities. If you have the absolute value of some stuff is less than a number. So this is what I call an in-betweener. Because if it's less than P, then it's between P and negative P. It's between those two numbers. So, you know, when you've got it going this way, that's the key, then you just take the number, you flop it over here, make it negative, repeat the sign. It's in between those two values. Okay? And then the third case here is if you've got absolute value of some stuff is greater than a number. Then either the stuff is greater than that number or the stuff is less than the opposite, the negative of that number. Okay? So you have to not only flop the number P to minus P, but you also have to flop the symbol from greater than to less than. All right? And again, so they've got good examples for both of these cases. You can go ahead on your own and look at those. I'll go ahead on the next page and do a couple of examples. All right, so first example, 4 plus 2 times the absolute value of x minus 2 less than 16. Okay. Now, first of all and always, the first thing you want to do is isolate the absolute value. You always want to have just absolute value of some stuff, whatever, then your inequality, then your number. That's all you want to have is just absolute value. So in other words, first let's start by subtracting 4 from both sides. So now we're going to have 2 times the absolute value of x minus 2 is less than 12. And then get rid of this multiplier. Divide both sides by 2. So now you're going to have absolute value of x minus 2 is less than 6. Now you're in the correct form. You've got just absolute value, inequality, number. Okay? Now you want to apply the correct technique. And again, you know, look back at the previous page. This is the case B from the previous page. Okay? It's a less than symbol. So in other words, it's an in-betweener. All right, so I'm going to take this, I'm just going to flop it over here and make it negative. So negative 6 is less than x minus 2 is less than positive 6. Okay? Only one more step, add 2 to both sides. So negative 6 plus 2 is negative 4 is less than x, adding 2 to both sides, is less than 8. Okay? So negative 4 paren to 8 paren. So it is an in-betweener. X is in between those values. In interval notation, the solution is negative 4, 8. Okay? All right, pause if you want. I'm going to erase just so I can scooch this up. All right, next example on this page. Absolute value of 3x minus 2 divided by 5 greater than or equal to 1. Now, the first thing we can do here is we can actually simplify the absolute value expression. Because if you go back, I think, to the very first page of the notes, first or second, just properties of absolute value. You know, we can split this like this. Absolute value of 3x minus 2 over absolute value of 5, okay, is greater than or equal to 1. Well, we know that the absolute value of 5 is just 5. So the denominator here just equals 5. Okay, so I've got absolute value of stuff divided by 5 is greater than or equal to 1. And so we can vastly simplify this by just multiplying both sides by 5. Because I just want to cancel these denominators. And then we end up with absolute value of 3x minus 2 is greater than or equal to 5. Okay. So again, go back to the table and look at the methods for solving. This is case C, okay, where we've got the absolute value of an expression is greater than a number. Greater than or equal to, doesn't matter, okay? So this is not an in-betweener. This is a case where I have to say, well, then either 3x minus 2 is greater than or equal to 5, or 3x minus 2. Okay. So in this case, I have to flop both the symbol and the number. So is less than or equal to negative 5. Because for this to be greater than something, I'm going to be going in this direction, or this is going to have to be less than or equal to something, okay? So that's the technique to get rid of the absolute value bars. Now just solve. All right, so 3x is greater than or equal to 7. X is greater than or equal to 7/3. Or 3x, add 2 to both sides, is less than or equal to negative 3. Divide by 3. X is less than or equal to negative 1. All right, so less than or equal to negative 1. Okay, so here's negative 1 with a hard bracket and everything down here. Greater than or equal to 7/3. All right, so 7/3 is what? 2 1/3, so that's like here. So everything up here. All right. And then we just write it in interval notation. So negative infinity, comma, negative 1 bracket, because we want to include that, union with bracket 7/3, comma, infinity, paren, because we always use a paren on negative infinity or infinity. All right, I'm going to erase and move on to the next page. All right, next page is just some practice problems. And here is what I will do. You do these, and you don't even have to print out this page. Oh, I guess I should have mentioned at the start that, if you wanted to print out the handouts, I will have them posted on our website. Guess it's too late now, huh? But anyway, go ahead and solve these 4 problems. Write your answers in interval notation for the inequalities. For the equations, it's just going to be discrete values for x. So just write x equals whatever. I don't care how you write it. But and make it very clear, circle or, you know, draw something around your answer, and then scan or take a picture and send it to me by this Sunday. So today's the 21st. Oh, so what day is Sunday? Sorry, today's the 21st. So by Sunday the 24th, just by regular quiz time, send me these 4 problems and your answers, and I will give you extra credit for that. All right? Okay, see you later.